Okay, so today I am going to discuss another problem from TIFR previous year question, and this is also a good problem. So the problem says that you have a point charge near a grounded conducting sphere, and that's why it will induce image charge. We all know that. Now they are asking that what is the charge density and how you should plot this charge density. So the black shading is proportional to the charge density, it is mentioned. So the black shading in this diagram shows that the right side of the sphere has more black shading, that means more charge density is there, and the left side it is zero. So these are the options for which, and you have to identify that what is the right option for the charge density, or mainly you have to find the what is the angular distribution of the charge density. So okay, now let's try to figure this problem out. So first, what should I do? So let's recap that what we do in infinite conducting sheet. Suppose this is the charge q and this is infinite conducting sheet at z is equal to 0. What we actually do that we put a negative image charge, that is minus q. Then our next job is to find the potential at some upper region R. We don't consider potential in this lower region because inside the conductor there is E field is equal to 0. So there is this is equal to constant. So doesn't matter. So inside this conductor the electric field is 0. So then doesn't matter that we calculate potential at all. So in this upper region we calculate VR, then we calculate that what is the normal component of V, that is del V del Z at Z is equal to 0. And the discontinuity of electric field give you the charge density, right? So the normal component of electric field in the upper region minus the normal component of electric field in the lower region, these two difference or the discontinuity of electric field give you the sigma, the charge density. So in this case, lower region it is 0. So only you have to only calculate the upper region electric field. So that will give you the sigma. And what is the result for this? We all know this and we all calculate this in our books and examples. So it is r square plus d square to the power 3 by 2. Okay. So this is sigma. So now the same technique we should apply, but the mathematics is little bit complicated because you have to do a bit more algebra here. Okay. So yeah. Now let's try to figure this out. So this is now the sphere. Okay. So this is center. This is your radius r, and let's suppose at distance a, you have the charge q. Okay. And this is your image charge, that is minus r q divided by a. And if you consider this distance as b, so what is b? B is equal to r squared by a. Now, suppose we want to calculate the electric potential at this region, that is R. So R is this point, and we want to calculate the potential. So let's join this line. So you have R, you have the distance B, you have the distance A, and let's assume now the angle is theta. So to you can calculate the distances of this potential R. This point we want to calculate what is VR. So this is VR, and you want to calculate what is VR. So let's now write down the formula. VR is equal to K. K is equal to 1 by 4 pi epsilon naught. Now let's write the potential due to the charge Q. So this is Q divided by, you have to calculate the distance. Now look at charge Q. This is the distance you have to calculate. So this is say r1. So what is your r1 vector? So this is your r1 vector. So r1 vector, you can write it as that r vector minus this is r vector, right? And this is your a vector, r vector minus a vector, right? So you can write easily, and you know the angle between r and a vector, this is theta. So the distance will be r square plus a squared minus 2ar. cos theta. Right. Similarly, you can now calculate the potential due to the image charge. The image charge is minus r cube by a divided by r remains fixed. In place of a, you now have to write r square by a, because b is what? B is r square by a. This is the distance, right? So in terms of, in place of a, you have to write r square by a. So r square by a whole square minus 2r into r square by a cos theta. Okay. Now you have to calculate the electric field. So electric field is equal to minus del V del R. And at which point you want to calculate the electric field? You want to calculate it at the surface of the spherical cell, right? So you want to calculate the charge density at the surface. So you want to calculate at R is equal to capital R what is the electric field. So okay. So you have to now take the derivative with respect to R. So let's another time write the potential formula. So for convenience, so kq divided by 1 plus r square plus a square minus 2ar cos theta to the power 1 by 2 minus, that is r by a divided by r square plus r square by a whole square minus 2r into r square by a cos theta. Okay. Now take the derivative. E is equal to minus del v del r, and later we will put that r is equal to small r is equal to capital R. So you have to consider also this negative sign, and now take the derivatives properly. I have already done this, so I am writing this directly. You can check it. Okay. The derivative, taking the derivative is not very complicated, so you can do this. Minus 2ar cos theta to the power 3 by 2. Okay. So minus half, here the power is minus half, so it will become minus half minus 1, that is minus 3 by 2. Okay. So yeah, and there is r minus r square by a cos theta divided by r square plus r square by a whole square minus 2r into r square by a cos theta to the power 3 by 2. Okay. 3 by 2. Okay. So now calculate, now put r is equal to r. So I am putting in place of small r, I am now putting capital R. So r minus a cos theta into r square plus a square minus 2ar cos theta to the power 3 by 2 minus r by a into r minus r square by a into cos theta divided by what you have here. This is r square minus r square by a whole square minus 2r cube by a cos theta to the power 3 by 2. Now you have to do a little bit just manipulation, nothing else. Okay. So yeah, now let's look at this manipulation, that is r minus a cos theta here by r square plus a square minus 2ar cos theta to the power 3 by 2. You have here a minus r by a, and now what you can do, take here a r cube by a cube. Okay. Sorry, let me write it first. It is r minus r square by cos theta. Okay. If you take a r cube by a cube, you have to another take a cube by r cube. And when you put that a cube by r cube in the power of 3 by 2, that will become a square by r square. So the first term become a square, second term become r square, and the third term become minus 2ar cos theta. Okay. So this manipulation is a bit tricky. You can check that. Otherwise, you cannot take the denominator common. Now you can take the denominator common. Okay. So now I am taking this factor outside the bracket. Now what remains is r minus a cos theta. Now r square by a square minus a square by r plus a cos theta. So a cos theta goes out. So finally you have kq into r square minus a square divided by r into r square plus a square minus 2ar cos theta to the power 3 by 2. Now as a greater than r, so you can just take a negative outside and do this a square minus r square divided by r into r square plus a square minus 2ar cos theta to the power 3 by 2. So your electric field is come out. So now you can also check that this image charge density will give you the total charge, so you can integrate this. So that is sigma is come out. Okay, sigma is the derivative, the discontinuity in electric field. Okay, so the derivative in the discontinuity in the potential. Okay, so that is come out. So sigma is minus kq by r square minus r square by r square plus a square minus 2ar cos theta to the power 3 by 2. Okay. You can also check that what is your image charge. So you can now integrate over sigma dot ds equal to sigma into r square sine theta d theta d phi, that is minus k q by r r square into square minus r square 2 pi. I am taking the d phi integration and it will come as 2 phi, and just you have to do this integral sine theta d theta divided by r square plus a square minus 2ar cos theta to the power 3 by 2, theta's limit from 0 to pi. This integration you can solve it. You just have to do that r square plus a square minus 2ar cos theta. You can take it as p square. Then your, sorry, there is a here. So that will, this is come, let's say suppose this is p square. So your r a sine theta d theta is equal to p dp. So after doing this substitution, you can solve this integration, and finally, if you put k is equal to 1 by 4 pi epsilon naught and all these things. Oh, yeah, sorry, there is a epsilon naught also. I forgot this. Sigma is actually sigma pi epsilon naught is the formula. Okay, so yeah, so if you finally put this, you can find that it will actually give minus r cube by a. Okay, so if they ask you that what is the charge density. So this is the right formula for the charge density. Okay, so yeah, if you have any comment you can check, and if this is the theta dependence, now you can plot what is the right, what will be the right figure. Okay, so I will argue you to do that problem later on, and also argue you to check that this integration, after this integration you will get this result. Okay, so you can check it. So this is the right formula for the charge density, distribution of charge density, and the dependence of charge density with respect to theta. Okay, thank you.